Okay, so this is our last live since it's week 8, and so I'm going to be covering the addition and subtraction properties of inequalities. So we're going to be basically solving inequality equations, which are very similar to regular equations. And this is something that you will see again if you move on to college algebra. So first, I just wanted to start with the symbols. So we're familiar with the equal sign, which means that things are equal. And we're now going to be solving equations that have other symbols. So we've got the less than and the less than or equal to symbols, the greater than and greater than or equal to symbols, and then there's a not equal to. So the not equal to has a slash through it through the equal sign, so it kind of makes sense. The less than or equal to and greater than or equal to are basically the less than and greater than sign, but with a line underneath which is coming from the equation symbol. So it's kind of combining both symbols because it means sort of both things. You're allowed to have both. So the difference between what we've done so far with linear equations and linear inequalities, there are some similarities. So they both have no exponents on the variable, and that's because they are linear. And that's what it means to be linear. An equation uses the equal sign. An inequality uses any of those other signs. Those are called inequality signs, meaning not equal. So they're not equal signs. They're the other types of signs. With a linear inequality, you can combine multiple symbols to create what is called a compound inequality. So with an equation, you only have one equal sign in your equation, but with an inequality, you could have more than one symbol. When you look at the possible solutions, for an equation, you get a single number as your answer, or you may have no solution or all real numbers. When you have inequalities, instead of a single number, you now have a range of numbers as your solution. So your answer is more than one number. It's a set of numbers. You can also have no solution and all real numbers. So the differences between the two are basically in red here, but there are similarities. And there are similarities and differences when you're solving as well. So if we're looking at solving an equation versus solving an inequality. So when you're solving an equation, you want to simplify both sides of your equal sign. So you'll have a left side and a right side. You simplify both sides. This means using the distributive property, adding your like terms. You basically do this, you do the same thing with an inequality. You simplify both sides using the distributive property and adding like terms. It's just, it's not an equal anymore, it's a different symbol, but you do the same thing. Then you usually use the addition and subtraction properties, so you either add or subtract on both sides. So with an equation, it doesn't matter. All you need to have is variables on one side, number on the other side. It's very similar to what we do with inequalities. We still add and subtract things on both sides, but with an inequality, you want the variable on the left specifically and the number on the right. And that's because this is how we read inequality symbols. With an equation, with an equal sign, it means the same thing left and right, because, you know, it's like a mirror image is not going to change what it means. But with the inequality symbol, reading it left to right is different from when you read it right to left. So if I go back to the list of symbols, going left to right, if you did it from right to left, it'd be a different symbol. So the order that you read inequalities matters, and we always read them left to right, which means that we want our variable on the left side. So you always want to have your letter on the left side when you're solving an inequality. So that's the difference. And so usually when I'm solving for x, I put x on the left anyway. So as long as you do that, if you always put your variable on the left, you're okay. After you do your addition and subtraction, then you do the multiplication and division. So that's the multiplication property. Most often we're dividing both sides by a number. And so it's called the multiplication property of equality when it's an equal sign. And you're just dividing both sides by the number in front of the variable. When you're solving a linear inequality, it's basically the same thing. The name of the property changes, so it has the word inequality, but it's basically the same property. You're still dividing both sides by what is in front of the variable, but you have one extra step, and that's in red here. If you're dividing or multiplying by a negative, the inequality changes direction. So if it's a less than, it becomes a greater than. Greater thans become less than. So basically get a mirror image. So your steps for solving are almost identical between solving with a linear equation and a linear inequality. Just with the inequality, you have one extra thing that you have to think about, and that's if you're dividing by a negative. So all the examples I'm going to do today are not going to involve multiplying or dividing. We are only going to do the addition and subtraction portion. So that way you get practice with that and how to write your answers before you start throwing in the division and having to worry about changing the flipping the sign. So the addition and subtraction properties, we learn them in terms of equality. They also hold for inequality, and they're basically identical. So I just have this box here. If you have A, and then you can fill it in with your symbols. So you can say, okay, if A is equal to B, then A plus C equals B plus C, or A minus C equals B minus C. If it's an equal sign, we know we can add the same number on both sides, or we can subtract the same number on both sides. We're allowed to do that. Well, it doesn't matter what sign it is. So if you have a less than or equal to, the same thing is true. So if you have A is less than B, you can add a number on both sides, you can subtract a number on both sides. Same thing if it was less than or equal to. So the key here is it doesn't matter what the symbol is in the box. And it looks like I forgot. I should have little commas there. I really missed my commas when I was typing that up. But it doesn't matter what symbol is in the box. The key is that you can add the same number on both sides or subtract the same number on both sides. And that's what we've been doing for solving. So this is not a new rule. It's just that we're saying that the rule applies to more than just equal signs. So that's the only new thing here. So the other thing, well, this is newer than just, that you can apply the rule to different symbols. This is definitely much newer, new to you, I guess, is how we write our answers. So when we solve, and it's an equation, you just say x equals 2, and then we'd usually put our number inside curly braces, and that would be how you would enter it in Connect Math. It would have these curly braces, and you just plug in the number. When you throw in inequality symbols, that's not going to work anymore because we don't have a single number as our answer. We have many answers, lots of numbers that work as an answer. So we have a new way to write the answers. So we can use what is called set builder notation, where you basically take your inequality and you throw it in a set with a certain notation here. You have this vertical bar kind of thing going on. Or we have what is called interval, not internal, interval notation. And so that is written with parentheses and brackets, and that is the most common notation. So I'm going to do everything with interval notation because that's the most common notation that you'll see. There is no interval notation if you're just solving an equation. So if you solve an equation, there's only one way to basically write your answer. But if you're solving an inequality, there's two different ways that you can write it, and we're going to be using interval notation. And what's nice about having this chart is when you go through and you solve these problems and you get whatever your number is, you just look at the chart and then you know how to write it, because the number is going to be the letter A. So whatever number you get, you just replace A with that number, and then you know how to write your thing. So just have this chart handy, so that way you can look back and say, okay, my solution looks like this on the left. Let me read this across so I know how I write my answer. So this is going to be very handy for you. So we will start with some solving here. So the first one on the left, we have x plus 3 is greater than 6. So we read this from left to right, and that's the greater than symbol. The larger part, the open part, is always facing the part that's bigger. So to solve this, we're only going to be using the addition property. And in this case, we're actually going to be subtracting. You're going to subtract 3 from both sides. The same way we solve anything else, it's just a different symbol. So we get x is greater than 3. And the hardest thing is probably going to remember to use a different symbol. Because if you change your symbol to an equal sign, it's not the same problem anymore. So you have to remember, don't accidentally write an equal sign, because it's a different symbol here. It means something else. This answer says x is greater than 3. So if I was to look at this on a number line, this answer is telling us that our solution are all the numbers that are larger than 3. So any number bigger than 3 will work in this inequality. So if I use 4 for x, I get 4 plus 3 is 7. 7 is greater than 6. That's something that is true. I can plug in the number 100. I get 103 is greater than 6. That's true. So any number that's bigger than 3 is going to make this inequality true. So we want to write our answers in interval notation. So I look back, I've got x greater than 3. And so this matches this solution, x greater than a. So a is just our number. So we have x greater than 3. So when we write our solution, we're going to write it like this with the parenthesis a, comma, infinity, parenthesis. So we're replacing a with our number 3. So it's parenthesis 3, comma, infinity, parenthesis. And that's how you write your solution. So I have a video explaining in much more detail why this is how the solution gets written. It explains set builder notation. It explains interval notation, how you graph these things, how you get the answers. I'm not going to go over all of that again in this video. In this video, this live, I'm focusing on the solving part. And so if you want more information on how we get this chart, you can watch that other video and it will explain all of that. But we're going to just use the chart as a reference and focus more on the solving. So are there any questions on this first example that I've done? All right. So the second one that I have here is y minus 6 is greater than equal to 12. So we want y by itself. We need to have it on the left. So I'm going to add 6 to both sides. And this gives me y is greater than or equal to 18. So I'm going to go back to our chart. And now we're looking at a greater than or equal to. So now we're on this row, which means that our answer is going to be written very similar to the other one, but we're going to have a bracket with our number. And if you look at the chart, you notice that there's brackets used when you have the less than or equal to or greater than or equal to symbols. So I just replace A with my number, which is 18. So I'm going to have a bracket at 18, comma, infinity, parenthesis. And that's how we write our answer. And that's just taking the proper row on this chart and then replacing the letter A with the number you found when you were solving. And we never replace infinity. Infinity is always there. So it just means it just keeps going. Are there any questions? Okay. So let's move on to some that are a little more complicated. Mainly, they just have multiple steps here. So we always want our variable on the left side. So our first example, we have 3q minus 7 is greater than 2q plus 3. So we have the letter q on both sides. When you're doing inequalities, you must put q on the left. The letter has to be on the left. So that is always the first thing that I do, is I write it. Well, first I'm going to rewrite it. Just, oops. I'm going to go back. I'm going to just rewrite it so I can make changes and it doesn't get confused. But first thing I do is I always move the variable because I know that has to be on the left. So I just take care of that first. So I have to take that 2q that's on the right, I have to put it on the left. So I'm going to subtract that from both sides. And then that will give me q minus 7 is greater than 3. And you want to be careful that your symbols, like your 7 and your greater than, don't look too close together. Because if you're messy with your handwriting, they could start to look very similar. So something that might be helpful for some people is just to maybe color the symbol so that way you know it's not a number, just to make it stand out a little bit more. If you think you might accidentally get it confused with a 7, if your handwriting just gets kind of messy. So I've got q minus 7 is greater than 3. And so we need q by itself, so I need to add 7 to both sides. So in this case, we have to do 2 steps here. And we get q is greater than 10. So now we have to go back to our chart so that we know how we want to write our answer. So we're looking for a greater than on our chart. Get the chart to pull up. There we go. So this just happens to bring us back to this one right here. This is our greater than. And so we're going to have our parenthesis, our number, comma, infinity, parenthesis. So parenthesis, our number, which is 10, comma, infinity, parenthesis. And if you are not very good at the infinity symbol, it's basically a sideways 8. So what I used to do when I was learning how to write this symbol was I used to turn my paper sideways and then write the number 8. That totally works. Some people might just take 2 zeros and put them close together, but you have to be careful that they're actually touching to kind of make the infinity symbol. Otherwise, you can just kind of practice. If I slow down, it looks really good. If I get messy, it kind of looks like a little funny and sideways or tilted, but that, it's a symbol you haven't had to write before, so it's going to take a while to kind of get used to writing it. So let's look at what we have on the right. We've got 5r plus 4. Man, all of these symbols are like, they're all greater than or equal to. I'm just going to change this one to a less than or equal to just so we have some variety here, because We haven't done that symbol yet. So I'm going to just change the symbol just for variety's sake. So we've got 5r plus 4 is less than or equal to 4r minus 1. So the first step is to move the r to the left. So I'm going to subtract 4r from both sides. So 5 minus 4 is 1. So we have r plus 4 is greater than or equal to negative 1. So once you've got your variable on the side that you need it, you move the number. So we're going to subtract 4 from both sides. And this gives us r is less than or equal to negative 5. Make my symbol a little better there. So we've got our less than or equal to. So I'm going to go to our chart. And we are looking at this row with the less than or equal to symbol. So it is basically like a mirror image of the greater than or equal to symbol. So you're just kind of reversing where the infinity is, where the number is, where the bracket and parentheses are. But now you have a negative infinity. So we're going to be writing this parenthesis, negative infinity, comma, our number, and then a bracket. So we have parenthesis, negative infinity, comma, our number, which is negative 5, and then a bracket. And then that's how we write this in interval notation. And this answer basically means that any number less than or equal to negative 5. So any number smaller than negative 5, or you can use negative 5. Any numbers that follow those rules will work in this equation. So there's more than one number that will work, and this is how we indicate that. Are there any questions? Okay. Thrown in. The one on the left looks simpler. It looks simple, but it's a little trick here, so that's why I threw that in there. The one on the right obviously is going to include more steps. So on the left here, we've got 4 is less than 1 minus x. I'm going to rewrite this. 4 is less than 1 minus x. So we have to have x on the left side, and our variable is on the right side. So in order to move it to the left, I need to add x to both sides. Now, it is not a like term with 4. So we now have x plus 4 is less than 1, because it's still a positive 4 on the left side. You could also write it if you wanted to. You can write this as 4 plus x. It doesn't matter because the order of addition doesn't matter. The key is that we have to add x so that it's on the left side first, because we always need to have the variable on the left side. So that's the little trick there. And once you've done that, then we're going to subtract 4 from both sides. And so that will give us x is less than 1 minus 4 is negative 3. And so now I'm going to go to my chart, and this puts us at the second row with our less than. And so we write this similar to the last example, but with parentheses. It's going to be a parenthesis, negative infinity, comma our number, and then a parenthesis. So we have parenthesis, negative infinity, comma our number, which is negative 3, and then a parenthesis. And so our solution is any number that is smaller or less than -3. Are there any questions on this one where we had to kind of move the x on the opposite side from where it is? Okay. So I'm going to rewrite the one on the right, which is a lot longer. We have 3 minus 4 times x, or h minus 2 is greater than or equal to -5h plus 6. So we need to simplify the left side. We need to do this distributive property and add like terms before we use our addition and subtraction. So we're kind of adding, more steps as we go. So first I need to multiply a -4 through the parentheses here. So that is going to give me, I still have my 3, and then I get minus 4h, and then a -4 times a -2 is a positive 8. And then I have my symbol, so I stop at the symbol, and then the right side is all staying the same. Now we need to add our like terms on the left. So I've got this 3 plus 8. So we're going to add those together, and that gives us 11. So I get 11 minus 4h is greater than or equal to -5h plus 6. So I always move my variable first, so I am going to add the 5h to both sides. We always want it on the left. And so that will give us 11, and then we have a -4 plus 5, which is a 1. So we just have a single h. We have a greater than or equal to, and then we have 6 left over on the right. So now I need to move the 11. So I need to subtract 11 for both sides. And that gives us h is greater than or equal to -5. So 6 minus 11 is -5. So now I'm going to go to my chart where I'm looking for this greater than or equal to. So greater than or equal to, so we're going to write our answer as a bracket, the number, comma, infinity, and then the parenthesis. So bracket, the number, comma, infinity, and then parentheses. So bracket, -5, comma, infinity, parenthesis, and then close the, or add that. And that's how we write our answer there. Is there any questions? All right. So these are actually my last 2 examples. So again, they could look, very complicated, but we just follow the same rules that you've been doing pretty much all term. We've been solving, we've been using these rules, so you should be very familiar with them at this point, although we haven't necessarily had to use the solving for x too much since we were focusing on quadratics. But we've got on here, on the first one on the left, 3 times x plus 1 minus 2 is less than or equal to 1/2 times 4x minus 8. So we've got multiple distributings we need to do. So I need to multiply 3 times x, so that's 3x, and then 3 times 1, so that's 3. And I have my minus 2 is less than or equal to, and then I need to distribute the 1/2. So 1/2 times 4x is equal to 2x, and then 1/2 times -8 is a -4. So we end up with 3x plus 3 minus 2 is less than or equal to 2x minus 4. And on the left, I have like terms, so I can simplify. I get 3 minus 2, which is 1. So I have 3x plus 1 is less than or equal to 2x minus 4. So now I need to put my x on the left. So I'm going to subtract 2x. And if you really want to get fancy, you can move your number at the same time. So some people like to do this. I can also subtract the 1 on the left and then put it on the right. So you can do those all at the same time. I like to, if I'm going to do that, I'm actually going to choose a different color. I like to do that in a different color just so it's a little bit easier to see that I was doing that. I don't do this too often though, because it can get confusing, but it's an option. You can do those both at the same time. So I get 3 minus 2, which is 1, so I have x, and then we already canceled out the 1, and then the 2 minus 2 is 0, and then -4 minus 1 is -5. So we get an answer of x being less than or equal to -5. So it just kind of saves you a couple steps, but it could be confusing for some people. Some people, you know, get confused on what's going on there. So I don't normally do that. But we've got a less than or equal to, so I need to go to our chart. And so that's the third row. So we're going to write our answer as a parenthesis, -infinity, comma, a bracket. And we're replacing a with the number. So we have parenthesis, -infinity, comma, our number, which is -5, and then a bracket. Are there any questions? Okay, so last one, it's longer. We have 2a plus 3 times a plus 5 is less than 7a minus 3a minus 1. Actually, I put parentheses there, plus 6. I'm actually running out of room there. So we need to simplify the left and the right side. So on the left, I'm going to be distributing the 3a, which is 3 times a, which is 3a, and then 3 times 5 is 15. So I need to bring down my 2a, then I get plus 3a plus 15. The less than symbol, and then I have 7a. And then this minus is really a -1 that we're multiplying through. So that's a -1. So a -1, I know it's kind of squished in there because I'm trying to fit it in. -1 times 3a is a -3a. And then a -1 times a -1 is a +1. And then I stop because the parentheses are ending. And then I have my plus 6. So that negative in front of the parentheses is just switching signs. So now we need to add our like terms on the left and on the right. So on the left, I've got 2a plus 3a. So that is 5a. And then plus 15 is less than, and then 7a minus 3a is 4a, and then I have a 1 plus 6, which is plus 7. So I had to combine a couple things there on the right. So variables on the left, so I'm going to subtract 4a from both sides. So that gives us 5 minus 4 is 1. So we have a plus 15 is less than 7. And then I'm going to subtract 15 from both sides. And that gives me a is less than, and gosh, this is one I can't do in my head. 7 minus 15. How if I type that in correctly? Negative 8. I definitely would have messed that up. So that gives us a is less than negative 8. So I'm going to go to my chart, and we are looking for our less than. So we're going to write it with parenthesis, negative infinity, comma, our number, parenthesis. So parenthesis, negative infinity, comma, our number, parenthesis. That's how we write our answer. So really printing out that chart, putting it on an index card or something so you can have it handy while you're doing your homework, while you're working on the quiz or something like that. That way you have that handy so you know how to write your solutions after you've done the solving. So are there any questions? All right. So this is the addition and subtraction property, basically, where you can add or subtract on both sides. And so essentially when we're solving an inequality, we're solving it just like we solve anything else. We just have to write our answer slightly different. And then you do have to worry about, oh, not this slide. If you're multiplying or dividing on a negative, but that is another property that I'm not going to cover in this one because it's just, let's start with the basics. But I do have a video that goes over all of this, and it summarizes everything in this section. So that one does cover the multiplying and dividing. So you can always skip the beginning part of that video and then go to like the second half or something where you start throwing in the multiplying and dividing and dealing with the reversing the inequality part. So we basically just did the first two steps here on this steps for solving, not the third one. But if you get a handle of this stuff, then moving on to that third one shouldn't be too bad. So thank you so much for joining. I appreciate that you've come to many lives. I am, glad that people have been coming to the lives and I haven't been sitting here by myself. So I really appreciate it. And this is our last one for the term, but hopefully that these have made a bit difference for you to help you, understand the math and everything. So I really appreciate you guys coming and watching the recordings. If you can't make it, it's really makes it worth me doing these for you. So, all right, well, that's all I've got for the night, and I will talk to you in the discussions, respond in the discussions. And of course, if you run into any issues, I am here to help you out. And you have until Tuesday to get everything in. So we're down to the last week of class, and then you're probably like, yes, I can move on from math. So some of you may be moving on to college algebra, and if you are, you'll see me again. But if you're not, you might be like, woo, yay, a break. So, well, have a great night, and I will talk to you later. Thank you. Bye.